Hey kids. Um, so it's been, we missed all of spring break. We were gone, and sometimes it's hard to pick back up where we were at. So anyway, today I'm just going to give you guys, I don't know, 10, 15-minute introduction to our review of chapter 19. Okay, everything that I am doing you should be able to find it through modules under Canvas, right? Go to Canvas modules, scroll down to the bottom, chapter 19. Okay, right here is chapter 19 definitions. If you click on that, there's a link to the Quizlets. From that Quizlet link, you should be able to get to my entire class, right? All of the chapter 18, 17, 16 stuff and stuff from last semester. You should be able to get to it through that link, okay? If not, type in D Holmes, STJ, and Quizlet search, right? Find the class. You should be able to find everything you need right there. Okay, we've had 3 reading quizzes, 1, 2, and 3, right, over each section. Now, we will have a chance to redo these. It'll keep your highest score. And so we'll do that tomorrow on Wednesday. Okay, so chapter 19, S1, S2, S3, 3 sections of reading quiz. You can do those tomorrow. Have a second shot at those. All right, here we have chapter 19 note outline. I put this in as an assignment, and it's worth 10 points. Most of you have done it and turned it in. I'm actually going to hand that back today, so you get that back. And then we've had homework 1. It's 20 things of matching, half a point each, so 10 points. Homework 2 is also 20 things of matching, half a point each. All right, homework 3 I gave you yesterday, Monday, April 3rd. And it is a 4-page worksheet, and it's a lot of just finding stuff on the periodic table, figuring out where it's at, or learning the properties of it. A lot of just kind of, an Easter egg hunt, treasure hunt kind of thing. Okay, homework 4 will be published today. It's not published yet, but I'll publish it. And that is a 10-point assignment. I think it's also matching. And then homework number 5, I'll publish that Wednesday or Thursday. And it's 20 questions, all multiple choice, half a point each. Okay, 10 points. So anyway, those will be the end of the homework assignments for this chapter, right? We've got 1, 2, 3, 4, 5, and the note outline. So those 5 things, 6 things, are your homework assignments, right? Then we also have the 3 reading quizzes. And then we'll have a test on Tuesday. Okay, not today, but a week from today, on April 11th. Okay, so let's look at chapter 19 notes, because I got a lot of stuff in there. And it's a good place for you to go to learn, refresh your memory on the stuff we've covered in this chapter. Okay, so if we click on the note outline key, right, these are all PDF files. This is the note outline key you guys filled out in class, turned in for a grade. And then my handwritten notes for section 1, section 2, and section 3 are found right here. So I'm going to click on my PDFs I've already got open down here. All right, so here's the note outline key, right? It's all filled in. You can download this, store it on your laptop. All right, properties of metals: they conduct heat and electricity, they reflect light well, which is a property called luster, or you can call it shiny. They're malleable, they're ductile, they form ionic bonds with nonmetals, they form metallic bonds with themselves. Okay. Anyway, you can read through this. Right, you'll find out that these are the most reactive of all metals, right? Softer and more reactive than other metals, are the alkali metals. You'll find out that they have 1 electron in their outer energy level. Okay, that's important. You'll find some of the uses here. And then alkaline earth metals, right? They are not naturally found in elemental form, again, because they're very reactive, just like the alkali metals. They have 2 electrons in the outer energy level. Some applications: transition elements, right? They often occur in nature as uncombined elements. I know that's one of your homework questions. You'll see either today or maybe Thursday. Okay, the iron triad, those are the elements in it. The coinage metals, right? Those are good homework questions, possibly test questions. And then you got your intertransition metals, which are your lanthanides, your actinides. We've got nonmetals, right? So on and so forth. Salt. Salt is when a halogen gains 1 electron from a metal. Okay, really in chemistry, any salt is when you have a metal bonded to a nonmetal, an ionic bond. That forms a salt. Okay, so it could be, a halogen, it could be something in the oxygen group or even the carbon group. All right, here's some uses of some of the halogens. Sublimation, that's an important word to know. I think it's a definition. It's when a solid goes directly to a gas without first becoming a liquid. Metalloids, semiconductors, right, the boron group. And for the elements, I just wrote the symbols rather than writing them all out. Okay, you can look in the book, periodic table in the back. We're building our familiarity with the symbols, right? Boron, aluminum, carbon, silicon, germanium, tin, and lead. All right. Allotropes, diamond, graphite, Buckminster fullerene, right? We read about those. We talked about those some previously. Nitrogen group, nitrogen, phosphorus, antimony, and bismuth. The oxygen group, okay, O2. Really, oxygen is just O by itself as an element, but it's one of those diatomic molecules, okay, that forms in pairs. So O2 is what we actually have in our air to breathe. Okay, not just individual oxygen atoms, but O2. It's a diatomic molecule. Sulfur, selenium, tellurium, and polonium. Synthetic elements are ones that we create. They're not usually found on Earth. Okay, that's an important point to remember. Transuranium elements have more than 92 protons. All of them are synthetic and unstable. There are some other synthetic elements that have less than 92 protons, like technetium, and I think the other one is promethium. All right. Okay, so there's that note outline. It's a great thing for you to read through, right? Refresh your memory to help you figure out where things are located in the book, right? Because they're in sections and it kind of follows along with the text really well. All right, yeah, let's go ahead and close that out. Okay, then we got the section 1 outline, and I'm not going to go through all of this for you, but these are my handwritten notes. They're really helpful. Take time to read through them. All right, a lot of questions will be in here. Questions sent from your test will come out of these notes. Okay, on metallic bonding, our book talks about it being a cloud of electrons, but it's often referred to as a sea of electrons, like all these electrons form this sea that kind of floats around on the metal atoms. All right, and they bounce from one metal atom to another, move around. Okay, that's why they conduct electricity so well. All right, that's why metals conduct electricity so well. It's because of the metallic bonding and the nature of how electrons are loosely held. All right, alkali metals, again, a bunch of properties, things about them. They like to form +1 ions because they have 1 electron on their outside energy level. Okay, the alkaline earth metals, they like to form +2 ions because they have 2 outer energy level electrons. All right, we call an outer energy level electron a valence electron. So they have 2 valence electrons. All right. Groups 3 through 12, the iron triad, the coinage metals, lanthanides and actinides. Now, some of the stuff, right, I can't put everything from our book into the note outline. So if you want to know uses and stuff of some of these, you're going to have to actually go look in the book. All right, you got to use your book, look them up. Metals in the Earth's crust, right? Most of them we can dig out of the Earth's crust. Aluminum is the most abundant most abundant metal in the Earth's crust. Silicon or iron is the second most abundant metal in the Earth's crust. Organ is a metal. Organ. Ore is a metal compound or mineral. Pure metal has to be separated from the ore to be used. So that's section 1. Let's go to section 2. Okay, this is on nonmetals. Again, a bunch of properties are listed here. All right, very helpful to know. Okay, the type of bonding they form. They form ionic bonds with metals, and with nonmetals they form covalent bonds. Remember, covalent bonds are sharing of electrons. Ionic bonds are stealing of electrons. Okay. All right. And when an ionic bond occurs, you're forming a salt. All right. Okay, hydrogen. 90% of all the atoms in the universe, because most of what's in the stars and in our sun is hydrogen. Okay. They can share electrons with nonmetals, or they can steal electrons from metals. So when you form, like, say, lithium hydride, hydrogen will steal an electron from lithium. All right. And they like to gain 1 electron or lose 1 electron. That's what they like to do, what hydrogen likes to do. Okay, or halogens. These are very reactive. Fluorine is actually our most reactive element of all of them. Okay, forms the strongest acid. Remember we talked about Breaking Bad episode, right? Chemical dissolution of a dead body. Okay, noble gases. Okay, you can read through those notes. Again, very helpful. I really recommend you take time to read through them. It doesn't take very long. And section 3 notes. Okay. Again, just read through these. They're really helpful. All right, it's a good outline. or different groups. Silicon is the second most abundant element in the Earth's crust. Now realize silicon is not a metal. So earlier we learned that aluminum is the most abundant metal in the Earth's crust, and iron was the second most abundant metal in the Earth's crust. But the most abundant element in the Earth's crust is actually oxygen. Okay, the second most abundant element in the Earth's crust is silicon. Okay, now that oxygen is not O2 floating around as a gas. Okay, it's like silicon dioxide for sand, or iron oxide, which is basically rust. Right, different oxides. So oxygen present in the atmosphere reacts with metals and forms, these nice stable compounds. So there's a lot of oxygen bound up in basically rock, right, in our Earth. Okay, allotropes, different forms of the same element. They have different molecular structures. As such, they end up with very different properties. Okay, graphite can be used as a lubricant. Diamond can be used in jewelry, right? Diamond's very hard. Graphite's pretty soft. I wrote with graphite when I made these notes. And then we've learned of a new one recently called Buckminster fullerene. You can call it a buckyball. It's basically got the structure of like a soccer ball with 6 and, well, let's call them hexagonal faces and pentagonal faces. Okay, 6-sided faces and 5-sided faces made together forms a soccer ball. Okay, there's a great picture of it in your book. Take a look at that. All right, and then we got the nitrogen group, the oxygen group, and synthetic elements. Okay, these are all unstable, so they're always going to fall apart. Some last a little longer than others, okay, but they don't last very long. Technetium, promethium, and all the transuranium elements are synthetic. Transuranium elements have more than 92 protons. Okay, so there's a good review of the notes. All right, so that was a good review of our notes. Read through those. It's really going to be beneficial to you. All right, now let's talk about our periodic table. I've told you before there's a lot of information contained in the periodic table, and you can learn a lot from it. Okay, now let's talk about the outside energy level electrons first of all. Okay, outside the energy level electrons, you basically say group 1 has 1, group 2 has 2. These guys here can do some different stuff. Sometimes I'll have 2, sometimes I'll have 3, sometimes I'll have 1. All right, they do some weird things. But if you go over to group 13, suddenly these guys all have 3. Group 14 all has 4. Group 15 all has 5. Group 16 all has 6. Group 17 all has 7. And group 18 all has 8. Except for helium, which only has 2. Okay, it only holds 2, but all these guys have 8. Now when things react, they want to, when I say react, I mean what they do is they chemically react with something else. And the way that happens is through sharing or stealing or borrowing outside energy level electrons, right? So I said all these guys in group 1 have 1 outside energy level electron. Okay, lithium has 3 electrons, but 1 in the outside energy level. Sodium has 11 electrons, but 1 in the outside energy level. Okay, potassium has 19, but just 1 in the outside energy level. So all of these guys would like to lose their 1 electron to become like helium, neon, and argon. Okay, because then they get a nice stable electron configuration. And that's what everyone wants to do, is they want to be stable, right? They want to be self-confident. They want to be, at peace with themselves. To be electrically stable, you want to have the electron configuration of one of the noble gases. Okay, that makes you stable. So your group 1 elements, they want to lose an electron. Group 2 elements, they want to lose 2 electrons. But if you go over here to group 17 elements, they're not going to lose 7 electrons to get there. They're going to gain 1. So bromine with 35 has 7 in the outside energy level. If it gains 1 electron, it becomes like krypton, okay, with 8 in the outside energy level. Now bromine would then be a -1 charge, right? So it'd be a -1 ion because it's got 1 more electron than protons. It only have 35 protons still, but now it's got 36 electrons. Okay? All right. Okay, so these guys want to form 1- ions. These guys want to form +1 ions. These guys want to form +2 ions. All right. Now sometimes these in here, 13, 14, and 15, depending what they react with, they'll do a little different things, right? But these guys over here in group 16, they pretty much want to form 2- ions also, okay? So if I take 2 electrons and add it to this hydrogen, or sorry, to this oxygen atom, now I'll have 10, and it'll be like neon, nice and stable, okay? So these guys want to gain 2 electrons, become 2 negative, and end up like a noble gas. All right, that's it for today.